Welcome to this DevTV presentation on the AutoCAD.net API. This is session 1, Getting Started. The objective of this session is to understand a few things about the .NET API. This will be a high-level overview of .NET and should give you an idea of what's happening on the system when a .NET application is loaded and run. In this session we will also discuss what it takes to create a .NET application for AutoCAD. We will be using Visual Studio to make an application that will have one command. This command will print a message on the AutoCAD command line. Let's dive in and discuss a couple of main components of the .NET API. These are the Common Language Runtime and the Framework Class Library. In Visual Studio, when you compile a .NET application, it creates an assembly that is a DLL or EXE. These assemblies contain code in intermediate language. At runtime, this intermediate language is interpreted by the Common Language Runtime. Because the .NET compilers create the same intermediate language, you can use different source codes such as VB.NET or C#. Assemblies that are processed by the Common Language Runtime are considered managed code. Sometimes you may see the AutoCAD.NET API discussed as the AutoCAD Managed API. The Framework Class Library, also sometimes referred to as the Base Class Library, contains services that form the building blocks for .NET applications. These libraries are in language-independent code and are installed with the .NET Framework. The Framework Class Library contains hundreds of classes that simplify programming with the .NET API. To make this more clear, here we have an execution model for the Common Language Runtime. First we start with source code that could be in any language that supports the .NET API such as VB.NET, C# or C++. This source code is then compiled into an assembly. Keep in mind that this .NET DLL is much different than a DLL created using Visual Basic 6 or a DLL that is created by some other compiler. The CLR then ensures that everything the assembly needs is available on the system, and it processes the intermediate language code and starts the just-in-time compiler. The JIT compiler is what gives .NET its platform independence, as there will be a different JIT compiler for different types of systems. The JIT compiler then creates the native code. An assembly will contain a manifest that describes the assembly. This description is what provides the IntelliSense and Object Browser capability when the assembly is referenced. The assembly also contains the IL code, which is interpreted by the CLR, and for AutoCAD the assembly will be a DLL. Later in this session we will use a utility named ILDASM-EXE, which is an intermediate language disassembler, to explore the contents of the assembly that we create. For an AutoCAD application, the first thing we need to do is create a class library which will create a DLL, and then we add references to AutoCAD's managed assemblies. Two of the AutoCAD managed assemblies contain the main AutoCAD.NET API. They are named ACDBMGD.dll and ACMGD.dll. One reason there are two DLLs is because of a product named RealDWG. RealDWG is used to access the DWG file and the drawing database, but does not have anything to do with AutoCAD. So if you are going to be using the .NET API for RealDWG, you would only reference ACDBMGD.dll. For AutoCAD, most applications will need to reference both of these DLLs. You will find these DLLs in the same directory where the AutoCAD executable is, or if you have the ObjectARX SDK, it will be in the InkWin32 or 64 directory. I would recommend that you install the ObjectARX SDK and reference the files from there. Let's go ahead and use Visual Studio to start an AutoCAD.NET application. Here we are in Visual Studio. I'm going to click on Create Project. In this wizard I'll go ahead and choose Class Library, and for the name we'll just call this Lab 1. And notice that the location that is set to is C:\AutoCAD.NET Labs. You would change this to the directory where you want to create these projects. Here's what we get when we run the wizard. We have a Class 1 VB module. In that module we have a public class called Class 1. Now we want to go ahead and reference the AutoCAD DLLs. I'll go ahead and right click on Lab 1, go to Add Reference. On the Browse tab, I'll go ahead and browse to the ObjectARX SDK. Then I will go to the ink folder. In here I'll choose acdbmgd.dll and acmgd.dll. Say OK. So that's the first part of creating an AutoCAD.net application. Let's just go ahead and look at the object browser. You can take a look at acdbmgd or acmgd.dll. So I'll go ahead and expand acmgd.dll, and you can see some of the classes that you'll be using here, and also acdbmgd.dll. After we add the references, we can add namespaces which can make our source code easier. In Visual Basic we use the imports keyword, and in C# this is done with the using keyword. The namespaces that are going to be common to most AutoCAD applications are autodesk.autocad.application-services, runtime, and editor input. These namespaces are available after the AutoCAD DLLs are referenced. To add an AutoCAD command, you use the command method attribute. In this example, a command hello world is created. When the user types hello world on the command line, the procedure hello world will be called. Keep in mind that the name of the procedure and the name of the command do not have to be the same as in this example. The attribute is added to the assembly as metadata, and this is used by AutoCAD to add the command. This example is using the simplest signature of the command method attribute. You use other parameters of this attribute to control the behavior of the command. This will be necessary in some situations, such as when the command is going to be accessing multiple documents. In that case, the command needs to run in application context, so you would use the command flags enumeration with the session setting. Now that we have a command that will run our procedure, let's use the API to print text on the AutoCAD command line. To do this, we use the editor class and the WriteMessage function. Notice that this function takes the string that will be displayed on the command line. To instantiate the editor variable ed, we use the editor property of the MDI active document, which is a property of the document manager, which is a property of the application. Now let's go ahead and go back to our Visual Basic project. Okay, here we are in Visual Studio again. And first thing I want to show you is that the Managed Assemblies have a setting that we need to change. So I'm going to go to Properties for this project and look at the Copy Local setting for ACDBMGD and ACMGD, and notice that it's true. We don't want this Copy Local to be true. We want it to be false. If it is true and we try to debug, then the Managed Assembly that we create won't load properly in AutoCAD, and none of our commands won't work, and you might wonder what's wrong. So just come back here over to ACDBMGD and ACMGD.dll and bring up the properties for it. I do that by double clicking and then set copy local to false for both of these files. Now that we have those set to false, let's go ahead and add our command. So I'll go back to the VB module and we'll use the imports keyword and bring in our namespaces. And I'm going to need runtime, and I know I'm going to write a message to the command line, and I know where this is. It is in the editor input. So now that we have those two imports, we can go ahead and start typing our code. I'm going to use the command method attribute, and the name of the command that the user is going to type in on the command line will be hello world. Then we need a procedure that will run when they type that in. We'll make it a public sub. Just call it hello world. And then here we want to instantiate an editor variable, so I'll type in dim. Then the variable ed as editor. That will be equal to application. I don't find what I want here in IntelliSense, so I realize that, oh yeah, I'll go back and use the imports keyword and bring in the application services. And if I do that, I won't have to type in Autodesk AutoCAD application services. Instead, I can just type in application and then document manager, MDI active document, and editor. Then I can call the WriteMessage method of the editor class. This takes a string, and that should be about what I need. I'll go ahead and put a breakpoint here, and we'll try to debug. So I'm going to go to the debug menu. Let's choose Start Debugging. It says a project with an output type of class library cannot be started directly. Well, that makes a lot of sense, so I'll go ahead and fix that. So we'll go to the properties of the project, go to the setting for debug, and we'll choose Start External Program, and I'll browse to the ACAD.exe. Say OK to that. And now we can try this again. Debug, start debugging, and it launches AutoCAD. Now I need to use netload to load that DLL, so I'll type that in. And let's make sure we have the right DLL. So it's AutoCAD.NET Labs, Lab 1, and then bin, debug. I go ahead and select that. And then I can type in Hello World. Our breakpoint is hit. Then I'm going to go ahead and go to debug and continue. F5. And we see Hello World was printed on the AutoCAD command line. So that's how we create an AutoCAD.NET DLL using Visual Basic. Let's go ahead and debug and then stop debugging. As you have seen, you use the netload command to manually load your AutoCAD.NET DLL. You can also have your DLL loaded automatically. You can have it loaded on startup or when your command is run. Here you see the keys that need to be used to add this capability. If you have an installer, you can add these keys to the registry. Now let's review the steps to create an AutoCAD.NET DLL. First, we need to have the project create a class library application. Then we need the references to the AutoCAD managed assemblies, and then we add the namespaces to the code window. We use the command method attribute and add a procedure that will be run when the command is run. The rest of these sessions on the .NET API will be on how to use the functionality provided by the classes in ACDBMGD and ACMGD.dll. After you create your .NET DLL, you may want to use these tools to help understand the behavior that is occurring with your application. You can use tools such as Reflector or IL-Disassembler to explore the contents of the .NET assembly. FuseLog Viewer will help you find out why a DLL is not loading correctly. If you want to check your application for conformance with design guidelines, use a tool named FXCOP. Let's go ahead and use the IL-Disassembler EXE and explore the DLL that we created. So I'll go ahead and click on this EXE, and I'm in the IL-Disassembler. Click on File, Open. And you can see it goes right to that directory because I looked at this earlier. So it goes AutoCAD.NET Labs, bin, Lab 1, bin, debug. Let's go ahead and open that. You can see Lab 1 class here that we created. And here's our Hello World method. Double click on that. You can see the intermediate language code that was created. And you can see that the command method attribute is used. Then we can also go ahead and look at the metadata info. Let's go ahead and show that. This is what the metadata looks like. And I can go to find and search on that command method. In the metadata command method. So this just gives you an overview of what these tools can do. Thank you for watching this DevTV presentation, and good luck with Lab 1. We will continue our AutoCAD.NET training in Session 2, where we will show how to use the AutoCAD.NET Wizard to create the application and how to get input from the user from the command line.